So in this video I'm going to talk about limits. So if I have a function which is defined to be f of x equals let's say 2 and let's say 5, and there are two conditions. It is 2 if let's say x does not equal 5. Actually let me does not equal 0, and this if it is x equal to 0. So how is the function going to look like, right? So if this is my axis, coordinate axis, then my function is going to look like let me extend this. Okay, so this is going to be, let's say this is 2 and this is 5. So the function is going to look something like this. It is going to be 2 when x is not equal to 0. So actually let me erase those markings. So it's going to look something like this. When x is not equal to 0, but when x is equal to 0, there is a gap here and the actual function's value is here, which is 5. Okay, so it's going to look something like this. So we say that at x equals 0, f of x is equal to 5, right? But if you are in a car and you're traveling along this this line here, you don't know that at x equal to 0 the function is going to jump out of 2, right? It's so small a gap that you'll assume that this road is a straight line. So if someone asks you hey, where are you proceeding, right? When your position is x equal to 0, then at what height are you? So the driver will say, well, I'm at 2, right? But he's not quite right, because at x equal to 0 it is equal to 5, right? So it's a small ditch there. So but we say that as x approaches 0, and this is the symbol for approaching, as x approaches 0, f of x approaches 2, or you can say that x equals 2, right? So this is written formally like this. It is written as the limit as x approaches some value, and in this case it is 0. As x approaches 0, as you get closer and closer to this ditch here, you are approaching the height, you are at a height of sorry, the limit as x approaches 0 of f of x equals 2, right? And that is because as you get closer and closer to this ditch, this hole here, but as long as you're not at that hole, your height from the ground is 2, right? But at that hole, your height is at 5. But we are not at x equal to 0, but we are closing into 0. You can imagine that it is 0.00000 going on till infinity, and maybe put a 1 at the end. You're that close to 0, but you're still not at 0, right? So your function's value will still be equal to 2, right? So I hope you get that point. So let's do a quick problem here. Let's say I want to find the limit as x approaches 2, let me change the number this time. Let's say x approaches 6 of let's say x square minus 6x over x minus 6. Okay, I want to find the limit, as this is a function, right? This is my f of x here. This is my f of x. So it might be possible that as at the function might look something like that, but what I claim is, because they're asking us to find the limit as x approaches 6, there must be some gap here where the function might take some other value which we have to find out. Sorry, we have to find this value, but not that value, right? So let's just substitute 6, right? The best you can do is that. So let's substitute 6. Substitute x equals 6, because sometimes, actually most of the times, this is what works, right? So in the numerator you get 6 squared, which is so f of x is equal to, if this is my f of x, so f of x at x equals 6 is equal to 6 squared, which is 36, minus 6 times 6, which is 36. So far so good, divided by 6 minus 6, right? So this is equal to 0 by 0. Okay, I don't really know the value of this. No one in the world knows almost. This is what we call an indeterminate form. Okay, this is not undefined, but this is called an indeterminate form, which can take any value, right? Because let me do a side here. Even if I assume that 0 by 0 is some value, let's say I'm assuming that 0 by 0 is k, right? Because I want to find k. So then I can multiply both sides by 0. Then this becomes 0 is equal to k times 0, which is true for all k's, right? This is true for all k's. So you put any k here, 1 2 3 4 5, a million, a zillion, anything, this equation will always be satisfied, right? So that's why we call that so 0 by 0 is k. So if k is any value, then 0 by 0 can be any value. So this is what we call an indeterminate form. Okay, so this is definitely not our answer, because 0 by 0 is not some specific value. So what can we do then? Well, let's see. If I bring this down here, okay. So if I split up the numerator, so this becomes the limit as x approaches 6 of I can factor out an x, right? I can factor out an x, and inside I'll get x divided by x is x squared divided by x is x, 6x divided by x is 6, right? So that's what I get in the numerator. And the denominator I have x minus 6. So we found the problem. We have found the problem, and now we can cancel out this. But you'll say, hey, wait, aren't you cancelling 0 in a way, because x is approaching 6, so this will approach 0, and the denominator will also approach 0. So you're cancelling zeros. That is not valid, right? But that's why the idea of limit exists in the first place, because x is approaching 6. Notice this thing here. It is not equal to 6. These terms are equal to 0 only at x equal to 6. That's what the idea of limits, where the idea of limits comes from. So this is not equal to 0, but this is approaching 0. I mean, this is 0.000, that's what I said, right? 0.001 or something, and this is also very close to 0, but it is, as long as things are not 0, and you're dividing the same things, it is always equal to 1, right? So you can cancel them out. So this becomes the limit as x approaches 6 of x. Well, this is as good as easy as a limit problem you'll get. What does x approach as x approaches 6? Well, they have already given us the answer. It is 6, right? So the answer to the problem is 6. I encourage you to graph this function here, and you'll really find that as x approaches 6, there's a gap somewhere around, and you might jump off to 6 or something. I don't really remember how the graph of this looks like. So yeah, so that was a quick problem, and so this limits are very interesting, and almost the calculus was born from limits, the idea of limits. I hope that you quite remembered all these fundamentals of limits, because so far I have done many videos on integration and differentiation which indirectly involved limits. So this is kind of a fundamental, because I haven't done much of theoretical videos so far, just problems in which I've assumed that you know things. So I've just started to do some theoretical videos, and I'll do a few more on limits, and I'll jump straight into problems, limits, a few rules, L'Hopital's rule, and a few other rules. So yeah, I hope you like it, and give me your feedback, and I'll see you in the next video.